plane y equals f of x is the name of this curve. This curve is the graph of the function f. Okay. F from some set A to B. Here, if A is the domain of the function f, that means the number, the collection of the set of all real numbers such that this one is defined. Means it's also a real number. And the B is the range of f. Range of f means the set of all possible values of this function, called the range. Okay. Then the inverse of f, whose domain will be V, and the range will be A. Okay. Use another way to express this relation is that suppose the domain of f only gets few points, maybe only 4 points. This is the set A, this is the set B. If this function is 1 to 1, because f is a function, it cannot, it's not a knowable value. From this point, has 2 different lines to the right. And this function is 1 to 1 means different. That is here and different values in B. So A is the domain of f. B is the range. Okay, maybe domain is a subset of the real number system. The range of the function is also a subset of the real numbers. Okay. The set of all real numbers. Then the inverse of f is a function from B to A. Therefore, the range of the function f b now is the domain of the function of f inverse. And the domain of the function f now is the range of the function f inverse. Suppose this is a 1, 2, 3, 4 squared. This is 1, 4, 9, and 16. Any question? No? Okay. So the notion of inverse function is essential. We have to study this. Once we have learned addition operation, we need to learn subtraction, multiplication, then division. Powers, then the roots. Same, a mapping, inverse mapping. Okay, mapping and inverse mapping. But if not 1, we have to restrict the domain in order to obtain some 1 and correspond to the original function. Right? I learned the opposite or inverse mapping, inverse relation. Okay, according to the explanation here or observation here, we certainly have. If f is 1 to 1, the domain of A, B is the range of f, and f inverse from B to A, then we have so-called cancellation equations, maybe. Yes, cancellation equations. Then we have f of x. Then f inverse is x for all x in the domain of the function A. See? Use this. X is mapped by f to f of x, then mapped by its inverse function again, will back to the original one. Similarly, if an element is mapped by this f inverse first, then f also undo I mean uh-oh. If x is an element of B, x is mapped by this function first to this number, then mapped by f. The result is the original number x. These two relations are called cancellation equations. Cancellation equations, okay. So once we already know some function is 1 to 1, then this function has an inverse function. If we want eliminate this one, we can apply its inverse. We can apply inverse to this one, then undo back to the original x. Okay? Now, if y, we already know f is 1 to 1, so give a value x in the domain of the function f, we have one and only one corresponding number here. Conversely, if y is given, then we obtain the one and only one number corresponding to y under the relation f. So x is also a function of y. So this curve, if it is a graph of a one-to-one function, has two names or two expressions. One is use y equals f of x. Y is regarded as a function of x. Also, under the relation, the assumption one-to-one, x is also a function of y. We use this notation. Usually, customarily, people like use x to denote the independent variable. So if some point in this curve means f of a, b equals f of a. So ab is in the graph of the function f. This one is equivalent to a equals, okay. Use that cancellation equation. We have f inverse b equals f inverse of f of a. And these two operations are cancelled. Or equivalency, a equals f inverse b. So BA will if we use x as the independent variable, then this is y equals f of x, or x equals f inverse y. If we use x as independent variable, y as dependent variable, then the relationship between this one and this one just interchange these two numbers. And this will cause what? A to the right. In y-axis, move up. B up. Move up. Here in the first position, move to the right. So these 2 points are symmetric about the straight line y equals x. A equals f inverse of b means BA. BA satisfy, this point satisfies this equation. And b equals f of a, or f of a equals b means this point, or this ordered pair AB satisfies this equation. f at A is B. This means f inverse at B is A. So, the graph of the inverse function of some function f is a reflection, reflection about this straight line. Reflection, 镜射, 反射,镜射. Yes, you can treat this one as a mirror. A mirror. Then this is the image of this curve inside this mirror. In mirror. Okay, so now we already reviewed something about inverse function. Next, we will consider the continuity and the differentiability of inverse functions. Well, if f is a one-one continuous function defined on an interval, then the inverse function f inverse is also continuous.